Imagine this. A massive storm knocks out the power grid. Gas stations stop working. Store shelves empty within hours. And suddenly, something as simple as clean drinking water becomes a real problem. Most people assume technology will save them. Plastic filtration systems, electric pumps, replacement cartridges ordered online. But then the batteries die. The filters clog. The replacement parts disappear. And meanwhile, somewhere in the corner of an old farmhouse, water is still dripping slowly from a simple clay pot. No electricity, no moving parts, no modern technology, just gravity. And a piece of knowledge humanity discovered centuries ago. A clay flower pot, a little activated charcoal, and somehow this primitive system can clean water that is safe to drink. No electricity, no pump, no expensive replacement filters. And here's what most people don't realize. This technology has existed for centuries, and it still works remarkably well, yet almost nobody talks about it anymore. Stay with me, because today I'm going to show you how an unglazed clay pot can actually filter water, why modern filtration systems are designed to keep you dependent, which hidden dangers most DIY guides completely ignore, and how you can build a two-stage water filtration system from simple materials that still works during real emergencies. And most importantly, this is not some random internet life hack, because when you make mistakes with drinking water, the consequences can be deadly. So today, we're going all the way down to the actual physics behind it. Most people look at a flower pot and think about plants. That's understandable. But fired unglazed clay is actually something very different. It's essentially a microscopic sponge. Its surface is covered in millions of tiny pores, so small that many dangerous organisms simply cannot pass through them. Large particles get trapped. Water molecules pass through, because water molecules are smaller than bacteria. So how does it work? Watch this. When contaminated water sits inside the pot, gravity slowly forces the water molecules through the tiny tunnels inside the clay. The water passes through. Bacteria and parasites do not. E. coli, Giardia, cholera. They get trapped. Because many of these organisms are larger than the pores inside properly fired terracotta. And suddenly, something strange happens. Clean water slowly begins to appear on the outside of the clay. No electricity, no electronics, no chemicals, just gravity and time. And here's where things become really interesting. Did you know that ancient civilizations already used porous ceramics to purify water? Even Roman legions transported water in ceramic vessels. And during World War II, engineers in the Pacific jungle returned to ceramic filtration systems when modern infrastructure failed. Because during a crisis, simple physics often outperforms complex technology. But if this method actually works, why does almost nobody know about it today? You probably already know the answer. A terracotta filter only makes money once. Modern plastic filters make money forever. Replacement cartridges, carbon blocks, filter subscriptions, maintenance systems, recurring upgrades. The business model of modern water filtration is not built around independence. It's built around recurring costs. As long as supply chains function, most people never notice. But the moment power grids fail, stores empty out, or replacement parts disappear, a high-tech filter suddenly becomes nothing more than useless plastic. The terracotta filter, on the other hand, requires no electronics, no electricity, no proprietary parts. Physics doesn't negotiate, it simply keeps working. So let's make this practical. The materials are surprisingly simple. One unglazed terracotta pot, a food-safe silicone, a clay shard or a real cork, a food-grade plastic bucket with a lid, an activated charcoal. That's all you need. But here's the critical part. The pot must be completely unglazed. No shiny surface, no coating, no paint. Because glaze seals the pores. And without pores, there is no filtration. Now comes the first critical step. The drainage hole at the bottom must be sealed completely airtight and watertight, because the water must never flow directly through the hole. It has to be forced through the clay walls themselves. Use a small clay shard fixed in place with food-safe silicone. Alternatively, you can seal the hole using a natural cork and beeswax, and then test it carefully. If even a single drop leaks directly through the hole, the entire filter becomes useless. Now for the plastic bucket. Cut a hole into the lid that is slightly smaller than the diameter of the terracotta pot. Place the clay pot into that opening. This securely locks the pot into the lid, while the lower half hangs down inside the bucket. That prevents dirt and dust from contaminating your clean water. And here's the part many people forget. The clay pot must be prepared first. During manufacturing, fine clay dust and minerals remain trapped inside the pores. That's why you must scrub the pot thoroughly using hot water, never use soap, and discard at least 3 to 5 full filtration cycles. Only after that will the water taste clean and fresh. But there's more. Because you need to understand this. Ceramic filters biology, not chemistry. Bacteria and sediment get trapped inside the clay. Dissolved chemicals do not. That's why you need a second stage, activated charcoal. Place a layer of activated charcoal between the clay pot and the collection container. The best approach is to place the activated charcoal inside a sieve positioned directly beneath the clay pot. This creates a two-stage system. Ceramic filters organisms, activated charcoal absorbs chemicals, and suddenly your DIY system starts operating on the exact same principles used in expensive premium filters. Now, to give you the complete picture, this system is not perfect, and that's exactly why understanding its limitations matters. Terracotta reliably filters many bacteria and parasites, but viruses can be much smaller. To be completely safe, you should additionally boil the water or chemically disinfect it. This becomes especially important during real emergency situations, such as filtering sewage-contaminated water. And like most filtration systems, this one also requires maintenance, because wet clay eventually develops algae, biofilm, and bacterial buildup. That's why you need to clean the pot regularly and occasionally sterilize it using dry heat. To do that, let the pot dry completely first. Then slowly heat it inside an oven to around 350 degrees Fahrenheit for 1 to 2 hours. Never place it into an already hot oven. That sudden temperature shock could crack the pot. And one more critical warning. Protect the pot from freezing temperatures. If water inside the pores freezes, it expands and cracks the clay from the inside. Even tiny hairline fractures can destroy the entire filtration effect. One more thing about filtration speed. 1 gallon every 4 hours. Now, you might say, that's extremely slow, and you're right, but you can increase the speed. Water flow depends on porosity, wall thickness, dust, and water pressure. So you can increase pressure simply by filling the clay pot with more water. The fuller the container becomes, the faster water gets pushed through the pores. Tall, narrow vessels work better than shallow bowls. You can also run multiple filters in parallel. 3 or 4 pots operating at the same time can easily provide enough water for an entire family. So in the end, maybe this is the bigger realization. Sometimes the most effective technology is not built from microchips and apps. Sometimes it's built from fired earth, gravity, activated charcoal, and patience. And now that knowledge is back in your hands.